Hello, hello. Swiss here. So the stream is live. Okay. Um, Today I wanted to start my journey on learning Zeek. So I'm just an average, I would say average, pretty average Python, JavaScript, TypeScript developer, and I do not have any enough knowledge about low-level programming languages, and neither I have good fundamentals in CS, if I'm being honest. Therefore, I decided to pick up some lower level language to upskill myself, learn more about programming in general, learn more about CS fundamentals, because in lower level languages, I have to be concerned about memory and like all those kinds of performance optimizations. And generally, I would say it's a little bit rougher, lower level languages, in a sense that I would have to code more to achieve similar things, not just npm install or pip install some library. And therefore, I decided to pick up some low-level language. And I do have a certain project in mind that I would like to build, and I decided to go with Zeek. Zeek seems like a more or less modern language. It's low-level enough. It is C compatible in the sense that I can use C libraries there as well. And the reason why I didn't go with C as opposed to something like as opposed to Zeek is simply because I wanted something more modern, and there is a certain hype around Zeek. And I was checking out the language reference on their website, and it looks pretty not bad. I guess it's something that I think I can learn. So we're just going to try it, and we're gonna start learning Zeek, and then probably on the next streams, once we once I feel a little bit more comfortable with Zeek, I'll be just building my project. So yeah, before I do that, just for the viewers of my previous stream, since I was configuring Emacs, I'm still using Emacs, I would like to give a quick update on my Emacs configuration because I modified a bunch of stuff since the last stream or video if you are watching this on YouTube. Right. So yeah, let's just quickly do that. So let's open up Emacs. And let me just, yeah, so we'll have this. Yep. So yeah, so let's just go to Emacs init.l. That's where I have my configuration. Just keep this open. Okay. So I hope, let me just double check if it's clear enough to see. Yep, I think it's fine. If anyone has trouble seeing this font size, just let me know. To be fair, we can probably increase it a little bit, but I think it's, let me just double check again. I think it's fine. It's not that bad. It looks alright, but we can consider increasing it a little bit more. Okay. So, as you already seen in my last stream or YouTube video, I used Emacs config generator to generate most of this stuff. However, some additional configurations that I added, they involve LSP. So I configured a three-seater, and for Python, I use whatever comes by default in Emacs for Python mod. However, I just added the three-seater mod as well. Again, everything is built in. I just need to kind of enable it and make sure that when I run Python mod, I also run the three-seater mod for Python. Then I have my linter set up. So I use the package here. So we just open this up. What did I just do? I pressed the wrong thing, right? Am I? Let's just get this one. Yeah, so I'm using graph because it's fast. It's good. It does the job for me. It's quite modern in compared to something like Black or Flake. So it just does the job, so I just use it. Okay, and it's pretty simple to configure. Just like as you can see here, this is all I need. Then I configured mod for Zeek and enable it for those Zeek files. Right, simple. Then I have some theme configurations. So I added Doom, a bunch of packages from Doom Emacs. So I have the mod line here. So it's not default mod line. It just looks nicer. Not really, at least from what I've seen, not a big difference in terms of functionalities, but it just looks nicer a little bit. Then we have nerd icons package. So yeah, where was I? Yeah, nerd icons. I believe this package is recommended by the mod line. I am assuming it is required for rendering like these type of icons. So if it's hard to see a little bit, but there is like small Emacs icon there. And then we have Nyan mod. So it's basically rendering this Nyan cat. I just saw it while I was researching about theming, and I thought it looks fun, so I just installed it. So what it does is it just shows you the position inside the file. So if I jump back to the beginning of the file, you see the Nyan cat is at the beginning, and then at the end is at the end, and then it just moves with uh, depending on how much I scroll within the file, right? And yeah, so I have the theme, which is in Doom themes package. I have Doom IO Dark theme enabled. I haven't spent a lot of time choosing the theme, so it just doesn't really matter. This is fine. So I just pick the one that looks all right. Okay, and then I have this ANSI color package, which basically enables color rendering on compilation mode. So whenever I compile some command, I use Emacs compilation. So it just shows some, it just enables the color rendering because otherwise it will be rendering the escape sequences and it just looks weird. Uh, yeah, so that's basically it for Emacs. So yeah, let's go back to the Zeek, right? Now, what I did is I went through the official website. So when you just come here, I read a bunch of stuff here. So I just went to learn and started reading from introduction. So I already read the overview. I read the reasoning behind Zeek and the comparison to other languages. So it compares with C++, D, and Rust. There is a lot of, I believe, let me see. No, not here, but yeah, I think in overview, actually, there is a lot of dunking on uh, C programming languages, which is very interesting. Yeah, so Zeek claims to be faster than C in most of the cases. So I believe, I'm not really sure if Zeek is actually faster than C. You can probably optimize both of them, but we could say they're like pretty similar level. So they're just fast, low level languages, right? And yeah, so I just went through these, and after that, I did a little bit of research. So there are a bunch of ways to learn Zeek, of course. It would depend on person to person. Probably one of the best ways to learn any programming language is to try to build some certain project. However, that project probably should be something that I'm already familiar with in terms of how I should build it. So the only variable that will be changing between different programming languages is the programming language itself. So I don't have to think about the implementation details of said project. All I need to think about is how do I accomplish the same implementation in different programming language. However, in my case, I'm probably not going to, yeah, I'm going to attempt building something new, completely new to me. So we are going to talk about project and what I'm going to build in Zeek later on because I might still change my mind. Uh, However, just to have some practical exercise and get myself more familiar with the language, because After I read this, I just feel like, okay, I just want to try it. Like, I need to code, I need to write some code, I need to check, I need to debug, right? So I found this resource. So it's called Ziglinks. Ziglinks is basically a repository with Zig exercises. It has a bunch of exercises here that I should fix, basically. So what happens is, whenever I compile this project, I'll be getting errors, and one by one, on different like smaller subset projects, I have to go through the compiler errors and just fix the code, right? I believe there is something similar in Rust, if I'm not wrong. So Ziglinks, Rust links. Yeah. So I think Ziglinks was inspired by this project. So it's also, I haven't tried like Rust links. I haven't tried Rust at all. So yeah, it's very similar tool for Rust. Basically, a bunch of projects that you compile that error, and you need to fix it. So yeah, we are just going to jump straight to it. Oh yeah, so like there are, I believe it's even here, right? So there are, they do mention this Ziglinks and book and a bunch of guys. Yeah, this book, I intend to probably read it. I'm still not sure if it keeps up to date with the current Zig version, because Zig is still more or less language that is being developed, and there are some breaking stuff as far as I can see. I might be wrong, right? So I intend to read this book, and I'm probably taking a break from streaming. Like, not that I stream too much, but I will have to travel for like a week or two. So I guess while I'm traveling, I'm just going to read this book. Initially, I was thinking to just record videos. However, it will be a little bit hard because I won't have all of my equipment with me. So the audio and everything, the video quality will struggle. So I just thought, nah, it's not that a big of a deal. So, but to not waste time, I'm just probably going to go through this book myself in my free time. And on stream, we are going to solve Ziegling's exercises. Right. So, oh yeah, yeah, they do mention it. So this project was initiated by Dave Gare, if I read this correctly, and it's directly inspired by the brilliant and fun Rustlings project. Indirect inspiration comes from Ruby Cons and the Little Lisper, Little Schemer series of books. Yeah, so they do create the Rustlings here. Hmm. Okay, so we're just going to jump straight into it. So we're going to clone this, all right? And yeah, I also changed from item to Ghosty. Ghosty is the terminal written by Zeke. It's written by, if I'm not wrong, by the same person who built the HashiCorp company. Right. So yeah, let's just clone this repo. Okay. Okay. Do I have? Okay, let's just I guess close this guy and just open it up. That's just a habit. The way I open my code editor. A bit weird. Oh, yeah, right. So let me just actually navigate here and then do it here. Okay. Hello. Okay. Thank you. Uh, yeah, Emacs, please stay alive. Okay. Right. So why I have now I have two Emacs instances running. Okay. This is interesting. So let me just paste this one, force quit. Yeah. Okay, we're good now. Right. So let's see. Okay, we just run zip build here. Mm, let me just do this, and then let's see if we can just run zip build directly from Emacs. Zig build. Sorry, it looks like your version of Zig is too old. Zig Links requires development build 0.14 def or higher. Please download development master build from download. Ooh, okay. So I do need to have a development build of Zig. Now, I have already installed Zig via Brew. I believe that's how I did it. And I believe the Brew version would point to uh, the stable version by default. And now I wonder if I can install the development build via Brew because I just like to have it in my package manager instead of building myself. Hmm. Install Zig development version, I guess. Z, yeah. So I'm not really familiar about the way to install packages on Brew directly from Git. I believe it's dash dash head. It seems like it. Yeah. Let me just run it and see if it will happen. And I hope it will just handle the no head is defined for Zig. Oh, wait. Brew install Zig dash head. Why am I not getting this? I wonder. Of Zig, you are causing trouble upstream. Oof. Did they just remove the head option for Zig? Oh well, that's unfortunate. I guess we need to find other way to install Zig now. Okay, that's not something I was planning to do now, but hey, we don't have a choice it seems. Oh, Zig, macOS. Toot, 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 toot. Is this the best? Is it really the best way to install this? Because if I install it this way, I'll have to manually manage it and manually update it. It's so sad that I can't install it from Brew. Oh yeah, it is here. They run correctly. Auto-updating also auto-updated homebrew. We have, yeah, no head is defined for Zig. Let me just double check what people say. No head is defined by Zig. No, that's not it. Oh well, okay, never mind. I'm just going to download it and try to use it this way. Mm, yeah, that's a bit um, sad because I would also have to manage my path in that case. Wait, this, can I do this? Zig version, yeah. If I'm not wrong, even my, uh, yeah, even my LSP is using 0.13. Ooh, oh boy. Okay, so let's do this, I guess. Let's just come here and download this guy here. Uh, yeah, let's just, I guess, do this, and then we, um, here. Yep, sure, allow. Then we need to move seek to code seek. Alright, so we just close this and then we have it here. Oh, tar x. Okay, unpack tar v cf. Wait, what is gzip verbose extract? Yeah, so it's xgzf. Yep. How is it? Yep. Doot, 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 doot. Now, okay, let's just remove this tar file. Okay, then we come to this seek. Mhm. And then do we have Zeek? Okay, so can I just do this? Uh, yeah, sure, Apple. Wait, did it just tell me that I can't run it? Oh boy. Okay, so I think uh, I have to do it this way. Okay, so now if I try again, yeah, okay, so it works. So there is hey, hola, hola. We have our first chatter today. Welcome, welcome. Sorry, I believe this is Spanish. I don't speak Spanish. The only word I know is hola. Right. Um, yeah, so we have seek. Oops, I didn't mean to do that. So now if we go to seek links, and then we just try to use um, seek macOS and then seek build. Okay, so it seems to be just working. Now, okay, so we can't use it from here. Now let me just quickly see if I can point my Emacs to use that newly installed Zeek version. I think it should be, yeah, so it's, okay, we have the Zeek mod, right? So let me just check, so Zeek mod Emacs. Let me see if I can point it to the specific version of Zeek. Okay, path to your Zeek mod. Okay, no, 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 that's not what I want. Oh, they do mention the fancy colors here for compilation mode. I wonder how do I point to the specific path of Zeek? Oh, there is no information here about this. Emacs, oops, Emacs, Zeek mode, path to Zeek. Mm-hmm. Mm-hmm. So this LSP mode, what do they use? Read file and Zeek, learn Zeek. Let me see if there is something here, maybe. Pop, 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 pop. LSP, LSP, LSP. Yeah, that's in the ZLS path, but not Zeek. Do we have anything in ZLS documentation? Hmm. Yeah, I don't think so. How can we check this? Oh, so I have a bunch of Z commands, but I don't see anything related to the path here. Yeah, let's just um, show me what I can do with Z mode. Let me see if there is anything that I'm missing. Oh well. Uh, yeah, I don't. This is probably something that I'm going to figure out later. Don't really care now. So what I'm going to do now is, yeah, let's just go back to the sequence here, and then let's just test it out. So what I'm going to do is to run project compile, and then we're going to, let's see, we're going to just copy this, and then we're going to paste this. Oops. So let me just should delete this. Yeah. Then we're going to try to build from here. Okay, yeah, so we have it working. Yep, I already see the output, and yeah, so what it does here, after we try to build this project, we get an error on the first ever file, so 001 underscore hello Zik. And yeah, let's just try to read it. So what is it saying? So let me just quickly open this up on the full screen, and then what we have here. Okay, we have an error. We have the okay, it's pointing to the Zik itself. So main is not marked pop. Main is not marked pop. Main declared here, referenced by. Okay, so if we directly okay, sequencing, don't panic. Read the compile message both something about main. Open up the source files not below and read the comments. Inside this will occasionally show up, but for the most part you'll be taking directions from Z compiler itself. Edit exercises 001 hello and transit build again. Okay, so now I can just directly go to the file here and then we'll get the error. Okay, so it's a little bit hard to see the comments, I guess. So let me just do this. So it would be, how do I, no. Forget how do I zoom in this thing. I mean, control 6, control plus, control 6, minus, control. Okay, that's what I'm trying to do. Oh yeah, so control X, control 6 plus. That's a little bit better. Yeah, that's better. Okay, so oh no, this is supposed to bring hello world, but needs your help. Zig functions are private by default, but the main function should be public. A function that is made public with the pub statement like so. hmm Perhaps some of this will help solvers are getting this little program. Okay, so the main has to be public, which does make sense. Wow, that's some complicated print though. Hey, at least we have some syntax highlighting. So let me just do this, and then we can switch back to. Um, we can just recompile this project again. So I just try it. Okay, yeah. So it seems that we passed the first test. So let's just jump straight to the second one. Okay, we have an error. Expected type expression found equals import. Okay, so yeah, this seems to be uh, an error with the variable name, I assume. Oops, this program is supposed to print a line like our hello world example, but we forgot how to import the Zeek library. The add import function is built into Zeek. It returns a value which represents the imported code. It's a good idea to store the import as constant value with the same name as the import. Please complete the import below. For the curious, imports must be declared as constants because they can only be used at compile time rather than runtime. Zeek evaluates constant values at compile time. Don't worry, we'll cover imports in detail later. Also, see this answer. Now, I'm just curious, where does it go? Compiles because it's lazy, because why not the compiler does not check it? What is this about? Sorry, definition why? Foreign is cause is kind of compared to war later, so from does not. Uh-huh. So it's the difference between war and cost. Const. Is it just the difference between what is evaluated at compile time and what is evaluated at the runtime? I haven't really seen war keyword that much in the like all the references that I read so far about Zig. It's okay. Yeah, I guess we'll just figure it out later. It's probably something, yeah, some additional read that I would need to do. Let's just continue. So what we need to do here, so it should be const cd, I guess then. So, oh yeah, and we get some completion here already. Uh, yeah, I think that's it. So let's just try to build it. Okay, we passed. So we are on exercise 3. It is going smooth so far. I remember there is something about exceptions here. I wonder if this print can have an exceptions, can return an error. Based on the type here, it should not. Well, let's see if my go to definition even works. Oh, it does work, so. Oh, yeah. Alright, so never mind. So let's hope these exercises will teach us more about all of this, right? Okay, so let me just scroll it up a bit. Yeah, so we passed second exercise. The third exercise. Okay, so we have compilation error and what is it? Cannot assign to constant. Okay, so let's just open this up. Oh, that's a big text. Uh, you know what? So let me do something. Um, I think I want to increase the font a little bit. That will solve a lot of problems. And if we go jump back to the top, and so let's try to do 40. Uh, let's see. Let me just see how it looks on the stream. Okay, I think it looks much better. Yeah, I'll just stick with that. And for me, it's fine as well. So the most important is you guys. So if you guys can see everything, we can live with that. All right, so whoa, that's a big font. Okay, let's just read the entire thing. It seems that we got a little carried away making everything const U8. Const values cannot change. U types are assigned and cannot store negative values. 8 means the type is 8 bits in size. Okay, that makes sense. Example, full cannot change. It is constant. Bar can change. It is variable. Var. Okay, so that's basically the. I mean, this makes sense. So const can be uh, changed and var can change. So one is immutable, one is mutable. Mm. Example, full cannot be negative and can hold 0 to 255. Bar can be negative and can hold minus 1 to 8 to 1 to 7. Okay. Full can hold 8 bits and bar can hold 16 bits. Interesting thing, right? When I'm using like something like Python or JS and TS, most of the time I don't even have to think about like signed and unsigned variables and their sizes, right? Because how do I call it? Everything is dynamically sized, if that's the correct term. So this is something I would have to learn too by myself, which is, yeah, like again, the reason why I'm trying Zeek now, why I'm learning lower level languages, because I'll have to think about more, and there is a lot of concepts that I'll have to catch up with. The funny thing is, like in software engineering career in general, if you are just working, you can achieve a lot of stuff while not having to know a lot of fundamentals and lower level concepts, because there is, hmm, how should I say? There is a lot of directions in software engineering in general. Like you can go um, like lower level concept direction. You can go specific web development direction. You can go to front end, and even front end itself, for example, has different specializations, if I can say that. So animations, for example, right? You can go cloud. You can perhaps consider going management route, right? You might be considering not working and building your own product. And for the most part, you don't really have to go deep on. There is a lot of, not that you don't have to, but there are a lot of directions where you can kind of skip all of the CS fundamentals. You can skip a lot of lower level concepts, but at the same time, I do feel like I'm missing out because even when you're writing something like Python, JS, right, there comes a point where the performance must be considered. So in some cases, in very critical systems, it is considered like what companies do. They would write their critical performance critical piece of software in some other programming language where it can accommodate it better. So for example, a common combination I would say would be something like if the main backend is in Python, then some performance critical software would be written in Golang, and then they would just communicate with each other, right? So it is kind of like still a good thing to know about lower level concepts, and it's good to have some more performant, slightly lower level, closer to the hardware type of programming language under your tool belt. And but yeah, as I said, it's not really necessary. However, I feel like it's good to expand your horizon. It's good to learn, and I am sure that I personally will have fun doing it. And that will also help me to kind of like secure my position in the industry because I would argue that JSTS and Python developers will be the first ones to be replaced by AI. That's for sure because that's the most common used and easily replaceable developers. On average, I'm not talking about every single JSTS or Python developer, that's for sure. But for an average like web dev guy, they can and would be replaced, that's for sure. Now, whether AI can reach that state and where we're at is a completely different discussion because I think we're still like quite far, but at the same time, it's impossible to make any predictions here because you never know what will happen tomorrow. So yeah, the reason why I'm doing it is because, well, I just want to upskill and I am sure I will have fun doing that. So I thought, why not? Hey, we can just learn all about this. Like you can see, we're on exercise three, and I already have to kind of like research additional stuff here. So the difference between signed and signed, the sizes, right? So how do I, for example, like what's the best practice whenever I code something? What's kind of like default size that I should put? Like what people do? Do they kind of like calculate um, the required size behind their like as they go developers, or do they just stick with some defaults, sensible defaults? For example, like maybe by default it's like 32 or something, right? So yeah, where were we? Okay, foo can hold 8 bits and bar can hold 16 bits. Okay. Mm, okay. You can do just about any combination of these that you can think of. Uh, U32 can hold 0 to, well, 4 million something, and then I64 can hold a big number. Please fix this program so that the types can hold the desired values and the errors go away. I'm now curious why unsigned can't hold negative numbers. Hmm. Yeah, that's something that I will be figuring out outside of the stream because I believe even this content might be a little bit boring to watch. And if I start researching all of those stuff, that might be even more boring. But again, if you think this is interesting to watch, well, just let me know and how can I improve what I can do, right? So yeah, please fix this program so that the types can hold the desired values and the errors go away. Uh-huh. Wait, let's see what error we're getting again. Cannot assign to constant. Uh, yeah, so the first thing we probably need to change is this should be var, uh, right? Because there is a reassignment here. And then can it fit in U8? I don't think so. 8 bits. Yeah, I don't. Yeah, it should be 16. Right. So then negative 11. Okay, so this should be I. Okay, but for the sake of it, our compilation just now just showed. Wait. That's oopsie. Just showed one, the first error, right? I'm just curious now what will happen if um I just leave this as it was. I'm just curious how the error will look like. So we already changed cons to var, so the first error should be gone now. And I'm just going to compile it again. Uh, Save file. Oops, yeah, sure. So type U8 cannot represent integer value of 31,000. Ziegler hint, there are 2 mistakes in this one. Okay, that's additional information. So okay, it just literally says that this type cannot support this value. Okay, simple. So let's just change it to 16 now. And then let's try again. So yep, yep. Then we just do this. Mm-hmm. Type U16 cannot represent integer value. Oh, am I wrong in the sizing here? Is it must be 32? 65, 60. How is it? Oh wait, it's 300. What am I? Yeah, I'm tripping. Uh, Oopsie. Okay, type UI can represent integer value of 0. Okay, so their error messages are not like different. Pretty simple, pretty clear. Huh. The funny thing is it can actually say what type it. But yeah, okay, fine. The Zig just treats us as a good developers that know what we're doing, so it doesn't have to handheld us. Right. Good. 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 Let me just see. There are no errors in the next line. Just explanation. Perhaps you noticed before that the print function takes two parameters. Note it will make more sense. The first parameter is a string. The string may contain placeholder, and the second parameter is anonymous list literal. Don't worry about this for now. With the values to be printed. Yeah, this is just like formatting, basically placing the um, to print out the variables. I think it's pretty simple and similar in most of the languages, right? Yeah, so let's just recompile it. Oops, what did I do? This should be I, yeah, because we need a signed integer to hold negative values. Okay, I don't know why, but we do have to do it. Okay, so we passed 3. Next is expected type expression found. Okay, so Zigbee, there are two things to complete here. Okay. Um, okay, let's learn some array basics. Arrays are declared with var foo. So I think this is basically the size, the length of array, and then the type of the values inside. And then we can initialize like so with some values. Okay, when Z can infer the size of the array, you can use underscore for the size. You can also let Z infer the type of the values so the declaration is much less verbose. Uh-huh. Okay. I wonder if I can just like omit the action. Oops. I did not mean to do that. Yep. I wonder if we can if I can just like declare the size with underscore and then just the type, not declare but like assign to the variable without the actual array itself. What will happen? They'll probably complain about something. Yeah, I guess there should be some other way to have a dynamically sized arrays, if there is any way at all. Yeah, because I know I think it's not that hard to code dynamically sized arrays yourself. Not that I know how to do it, but it's not that hard. Okay, so get values of an array using array index notation. Okay, that's simple. Set values of an array using array index notation. Okay, simple. And then to get length is dot len. Okay, so yeah, what do we have here? Problem one. This const is going to cause problem later. Can you see what it is? How do we fix it? Wait, which error we actually got now? Is there a type exception found? Oh yeah, so the issue is I think looks like we need to complete this expression. Use the example of the set 4 for the fourth element of some parser. Primary. Okay, so what we want to do here is um, access the value of some primes by index. So the fourth will be 3, and then so kind of like assume the length should error out now. Yeah, this makes sense. So this should be length. Let's just say that, and then we'll compile it again. Yeah, okay, so we do have an error now. Cannot assign to constant. Uh, what is it talking about? Ooh. So what happens here? So this part is we are trying to reassign the value of the first index to 2. Now the reason why we can't do that is because I assume, well, based on what we learned so far, it should be just that this should be var, I would imagine. That should fix it. Uh-huh. It did. Okay, so if the array created with cons, the values cannot be reassigned. I guess that makes sense. That's nice. In JS, like it kind of prevents you to reassign the values when you have cons as well, but you can still reassign the indexes of arrays or key like the key values of object. Doesn't really care. Um, yeah, what I want to try is what will happen if I kind of like no, that's not what I meant to do. So kind of like this part. I think it will already complain. Uh-huh. Unable to, oh yeah, okay, it's kind of already like telling me the issue, unable to infer an array size. So what will happen if I just do this? You know what? I'm curious if we try to compile this, what will happen? Expected. Did it really recompile the fourth exercise or? So wait, what will happen if I, oh, okay, because we passed the fourth exercise, it just doesn't do it again. We need to check if we can kind of restart this thing because sometimes I just want to do the, okay, we can just do slash dn. Uh-huh. Mhm. So slash dn, and this was 004, or we can just say 4. What is this? Expected the, oh, I'm sorry. So this should be equals a sign. Okay. Okay. Enable to infer an array size. Okay, just yeah, it kind of like literally says the same thing. So uh, yeah, what we're gonna do is we're gonna need to change this to var again. Yeah, and then what I wanted to try is to try um, to have an empty array. Yeah, I'm just very curious if it will just work. Indexing into empty array is not allowed. Okay, yeah, this is fine. We'll just need to figure out how to do that later. Yeah, so what I'm trying to do is like have your average developer's array dynamically sized, and yeah, I don't think it would be that simple, of course, but I tried. That's um, helps me to understand the language a little bit better. Right. Okay. So let's just go to the next problem. Expected type expression found leaked. Okay, so we probably, yeah, will come here. This should be an array, right? Combination of these two arrays. Okay, so let's read the explanation first. Zig has some fun array operators. You can use plus plus to concatenate two arrays. Oh my god, what? Wow, okay, that's an. What is this? What is this? This syntax is a bit. Uh. Huh. I'm not sure if I'm. It's simple. I'm not sure if I necessarily like this syntax. That's a bit weird syntax, to be honest. Why plus plus? Why not plus then? No, what will happen if I plus pass two integers or two strings? Can I pass them or is it? Yeah, I guess the differentiation is that like normal plus would just work on integers and all the types that are compatible with like math operations, and plus plus is more of a special operator. Is it array specific or is it will it fail on or is it like trying to guess how to do additions? But no, I don't think it will be actually guessing. I'm assuming it's just an array operation only. Yeah, that would be weird if Zeke tried to guess. But let me just double confirm that my mic is on. Yeah, we're good. hmm Uh, yeah. Okay. You can use star star to repeat an array. Oh yeah, okay. It says here that yeah, the plus plus and star star only operate on arrays while your program is being compiled. The special time zone is Zeke as parlance as comp time, and we'll learn plenty more about that later. Okay. Okay, so it's evaluated on the compilation time. So which means that if we have a dynamically sized array and we try to do that, it should not allow us to do that. Okay. Okay, so then what we can do here is we do lee star star and then we do e. So this should work. So I'm just going to straight and try to compile it again. Mm-hmm. Uh-huh. Now we have another error. So expected time expression found. Yeah, so question, question, question. Okay, please set this array using repetition. It should result in 1 0 0 1 0 0. Okay, so it would be 1 0 0 1, and this star star tree should just multiply by 3, and we'll get the resulting array as shown here. Oh yeah, save file, sure. Okay. Uh, let's read what it says here. Okay, that's all the problems. Let's see the results. We could print these arrays with lead 0, 1, yeah, by index, but let's have a little preview of Zik for loops instead. Okay, we're getting into it fast. That's nice about this exercise, I guess. We are both writing some code and reading some explanations. That's much more. Not only that teaches me better, I would assume. It's also just interesting to do for real. So yeah. Okay. So mhm. For lead. Okay. So we choose an array on on which we iterate on. Then we specify the I assume it would be the value itself this way. And then, what is this bit path? Oh yeah, that's an array, and then we get the value. I wonder how do we get the index? Uh, will it be something like this? Okay, that's an invalid syntax, I assume. Uh, extra capture in for loop. Okay, I don't think that's how we do the index. Oh, not even sure. Like, yeah, because most probably like it's not really necessary because like there's like thousands of ways to like get the index. Because I would assume we can just can we do this? Well, it doesn't complain, but yeah. I would assume we can just like iterate over length and get index this way. Okay, that will be something that we'll do later. We need to explore, explore, and explore. Oh yeah. So wait, where was I? So it will be control speed. Then we yeah. I'm still getting used to Emacs. I'm already pretty fast, but not as fast as I would like to be. So yeah, getting confused here and there. Wait. Okay, so yeah. Um, expected type expression found. Yeah. So the question marks again. Now that we have learned about arrays, we can talk about strings. We already seen Zig string details. Hello world. Okay, Zig stores strings as arrays of bytes. Okay, so that makes sense. Is almost the same as hello. Okay, we'll see what Zig strings really are in exercise 77. Ooh, okay, we're quite far from that. Notice how individual characters use single quotes and strings use double quotes. These are not interchangeable. Oh, okay. So this means that we can't really do this, I imagine. Oh, Emacs, what are we doing? So, what kind of error it will show me? Expected expression found in valid bytes. Yeah, okay, that makes sense. Oh, yeah. Oh, wait. This one, this one, this one, this one, this one. Yeah, okay. Which error we had? Okay, so 27, line 27. Problem 1. User expert bracket syntax to get the letter D from the string. Stardust both. Okay, so we can access like characters of a string by index, which makes sense. 0, 1, 2, 3, 4. So 2, 3, 4. Okay. Let's just save this file and recompile it. Okay, so we're on the next error. Ha. Use the array repeats as operator to make ha ha ha. Okay, so we can even do this as well on strings then. Oh yeah, I mean, we told us that plus plus and star star is like a real-only operation, but if we consider strings are kind of like just an array, it I guess makes sense. So that would be 3. Oh, and now next error, major and tone. Okay, so use the array concatenation plus plus operator to make major tone. You will need to add space as well. So plus plus, I guess we can like do this. Now I'm wondering what if I do it this way. So single quotes for one character. Expected indexable found comp time. Oh yeah, okay. So because this is not strings, therefore it's not technically an array. Therefore we cannot use plus plus or star star here, which makes sense. And this is found comp time int. Oh, comp time int because of the space. Why int? Mm-hmm. Uh, yeah. So let's try to build. Okay. So yeah, we pass. So let's read what it says here. Yeah. That's all the problems. Let's see our result. USS int that S3 and S3. You guys will notice I have put U and S inside the array. These placeholders. This tells the print function to format the values as UTF-8 characters and UTF-8 strings respectively. If we didn't do this, we would see 100, which is decimal number corresponding with the character in UTF-8, and there indicates all the strings. While we're on this project, C ASCII encode character would work in a place for U because the first 100 digits are the same as ASCII. C ASCII encoded character would work in a place for U because 100 digits are the same. Okay, so what it's saying we can use the ASCII here and just put C. Uh, yeah, okay, sure. Let's move on to the exercise 7. Yes, we'll um, probably do up to 15. That'll be enough for the day. I might, not sure if I want to do something off stream or not. Probably no. I'll be just reading mostly because I still need to read a lot.
Mm, yeah, and after my stream break, we'll just come back and finish this up. Yeah, that will be a big, um, that will be probably a big break, but hey, it is what it is. We need to travel. Right. Okay, so here is a fun one. Zig has multi-line strings. To make multi-line strings, put like slash slash, backward slash slash, at the beginning of each line, just like quote comment but with backslash instead. Aha. So that would be this. Wow, okay, that's a weird way to declare multi-line strings. I don't have enough experience to remember, but okay, fine. To be honest, it's not that bad. Yeah, like the Biden way is like to do triple calls like this, and then your string just goes behind this calls. But I guess that might be weird, like if you see it first time as well. Yeah, it's just a matter of habit at this point. So, uh, yeah, so let's just let's go delete this. Oh, we deleted too much. Yeah, so uh, yeah, let's recompile this. Save file, yeah, sure. Expected this output, but found that out. Please fix. What did I press? Oh, oh yeah. Okay. Wait. It registers the spaces. Yeah. Wait. Yeah. We have extra spaces here, so it makes sense. Makes sense. Sure. Mm-hmm. Okay, we're good now. Let's see. Okay, we have question marks again. So what's the matter here? Quiz time. Let's see if you can fix this whole program. You'll have to think about this one a bit. Let the compiler tell you what's wrong. Start at the top. Okay, so what is this nonsense? As a string, does it really matter? Note, useSize is an assigned integer type used for sizes. Okay. The exact size of the useSize depends on target view architecture that you could take. We could have used U8 here, but useSize is a thematic type to use for indexing. There is a problem on this line, but useSize isn't it. Mm -hmm. Note, when you want to declare memory and array in this case without putting anything in it, you can set it to undefined. There is no problem on this line. The following lines attempt to put Z, I, and G into the Lang array, which is created by indexing array letters with the variable X. As you can see above, X1 to begin with. Uh, it's a variable X1 to begin with. Okay, so what do we want to do? I would like want to do this, and then uh, Zeke. It probably wants me to like print out some word. Wait, Zeke what? F if y, y what? Okay, so let's just try to put this number. So line two letters. Uh, the X is one. Oh yeah. Okay, so I guess it wants us to have Zeke word. Okay, Z three. 0, 1, 2, 3. So zig G, so this should be the last one. 5. And then we have, so this should be, um, wow, that's not what I meant to do. Oh, I'm sorry. So this should be X. Mm-hmm. Okay. So what happens if we compile it now? Can I assign to constant? X is 3. Uh-huh. Yeah, so this should be a var, and yeah, okay, that wasn't really hard. Taught me that I'll have to think about it more. Okay, oh, interesting. Okay, we I guess we found uh, a way for me to declare like not really dynamically. Okay, this is not a dynamically sized array, but declare an array without assignment first. So yeah, at least we can do that. So it's the keyword is undefined here. And then let me see. Hmm. Yeah, nothing really special. Everything else is something that we already learned. Okay. Now, expected type boolean found comp time int. Okay, so that's about something about foo. Yeah. Okay. Now we get into fun stuff, starting with the if statement. Okay, if true, else. Okay, very simple syntax. 6 has the usual comparison operators such as equals equals, less than, greater than, not equals. Okay. The important thing about 6 if is that it only accepts Boolean values. It won't curse numbers or other types of data to true or false. Okay. That's a good thing. Yeah. Explicitness is always a good thing. It's like in both JS and Python, oof, the behavior can be crazy sometimes, especially with the Python's none, which is like basically null kind of thing. Yeah, I think the Python's none is essentially a null. In other languages, null, new. And the behavior there sometimes might be very weird, like when you are checking like the difference between checking explicitly with like equals equals and the different yeah, and it's just like putting it if like directly like not none or something that can cause a lot of issue. So now I wonder if I uh can I say like true? Uh-huh. What if I say like not true? Okay, so this works, seems to be. But now what we want to do here, I guess, is we want to check if foo equals to 1. So that's a very simple fix. Yeah. Yeah, both Python and JavaScript, the if conditioning behavior, like the way that it converts all the types and try to like booleanize everything whenever you put it inside the like parentheses of if into condition place, it does not really behave well. Now, most of the time it's fine, and that's the point of those languages that you can get you going fast. But whenever you encounter some, and you will eventually encounter some weird behaviors, that will be very annoying. And it basically like makes you like forces you to spend a lot of time with the language to actually know all the quirks about all the ways around these conditions and how they work. So yeah, that's a bit annoying. And I like the fact that in Zeek I have to be very explicit on what I put inside my if. That's nice. Yeah, so let's try to compile it, say file sure. Yeah. Okay, so next error, expected parentheses found question mark. Okay, so we have question again. If statements are also valid expressions. Okay, so we can like kind of inline it here, right? So that would be if this count is true, the price should be yeah. So that would be if this count um, yeah, since it's a boolean by default, we can just put it directly here. Then the price should be 17. Uh-huh. Oops. 17. Else it should be 20. Mm-hmm. Yep, and it works. Okay. Next. Okay, we have question marks and I see while loop. Okay, we have the loop. Seek while statements create a loop that runs while the condition is true. This runs once at most. Hmm. Runs once at most, makes sense. Remember that the condition must be a Boolean value and we can get a Boolean value from conditional operators such as, yeah, so it also like forces us to be very explicit about what we put here. Please use a condition that is true until n reaches 1084. Okay, so if we reach this, it should just stop. And so it will iterate like 1000. Oh, no. It will iterate what, like 1022 times? Yeah. Then we have print the current number, which is printing, multiplying by 2. Okay, we haven't really learned about this. Yeah. So it just multiplies by 2 and assigns it immediately, I guess. Yeah, so this is simple. To be honest, I guess it's fine. It's very nice that it didn't go through like very, very basics of the syntax itself because yeah, like that's you should probably know this. And if you are a total beginner, I guess like there are other resources that will teach that. Uh, yeah, I'm not really sure if there are any developers, the complete beginners that start with Zeek. That would be cool. Because it's like uh, learning some lower level language like teaches you the fundamentals from the beginning, and you won't be missing out like me later in the career. Uh, yeah, so let's just try to compile. I think it will be fine. Expected this output, but found n equals 2. Uh, yeah. Wait. Yeah, sure. This might be wrong, but why did it? Okay, it did pass. Oh. Oh yeah, wait, hold on. What I was doing, like while n equals 1024, that's what I put at the beginning. Like, yeah, it doesn't make sense why the loop will not be running because the condition is never true. Yeah, it was false from the beginning because the n was assigned to 2 initially. Oh my god, what am I thinking? Yeah, I guess I'll need to take a little break soon. How long am I streaming? Oh, the time flies so fast. Yeah, okay, let's just continue. That's a bit embarrassing, but it's fine. So yeah, Zeek while statements can have an optional continue expression which runs every time the while loop continues, either at the end of the loop or an explicit continue is invoked. We'll try those out. Uh-huh. What an interesting way of writing this. Uh-huh. So do something with even numbers that are less than 10. Uh-huh. Wait, while loop can have an optional continue expression which runs every time the while loop continues, either at the end of the loop or an explicit continue is invoked. Out. Okay, so basically it's like probably it's like being used mostly to like control your loop. So in our case, because our loop condition is n less than 1000, we can use this expression here to control that end, so we can kind of like control what happens to our loop. Now, what do we want? So we can get the desired result, as in the last thing, so I want this to result to be n24. So we probably want to assign something here. So what if we, yeah, just add the same thing that we had in the previous exercise. And yeah, that's basically it. So, so compared to what we had in the previous exercise, so it's basically running the same thing, but here it runs at the end of the, yeah, at the end of the loop, while there it runs inside these conditions. So I guess that's a way to control the loop. Hmm. Now wait, oh, I just realized something. Why it says 1,000? Shouldn't it like, okay, so wait, 222. Oh yeah, yeah, okay, because the next one is basically this, so yeah, makes sense. Okay, okay, yeah. Yeah, makes sense. Yeah, yeah, yeah. I'm just getting confused. Hmm. Next, exercise 13. How many exercises we have? Let me see. Does it say it here? Exercise, I can just check here, I guess. Uh, I was just about to say, do we have 900 of them? Okay, just 109. Okay, that's not a lot to be honest. Comp time. Ooh, we do have like 10 exercises on comp time. Async and C. Okay, testing. Okay, that's a very nice. I guess we'll cover a lot of topics this way. That's not all, just 100 exercises. Like we're already done with um how many of them? Like 12. Yeah, we're on to 13 now. But yeah, I guess it will be getting harder and harder. So we'll have to Google some things and learn some things. Yeah. The last two exercises were functionally identical. Continuous expressions really show their utility when used with continuous statements. Mm-hmm. Mm-hmm. The continuous expression executes every time the loop restarts, whether the continuous statement happens or not. Yeah, so this is a way to control the loop. But uh this should be something that is being like kind of way to skip the loop, right? So I want to print every number between 1 and 2 that is not divisible by 3. So yeah, okay, so basically if it's divisible by 3, so if we mod 3, yeah, this was not shown, but yeah, it's available, I guess. So continue means like skip this iteration. So at this point, when the continue is here, it will just like rerun the loop without reaching this line, the print line. And it shows that my stream is unstable again. I lose, alright, so I hope we are good. Yeah, I hope we are fine. Yeah, so let me just like quickly um, acknowledge the. I accidentally refreshed my chat. I need to kind of like, yeah, I need to kind of like deal with this Twitch chat. Set it up so it shows up on the stream. Hey, and we have the follower, boss cans. Thank you for following me. I hope my streams are interesting. I'm just, yeah, we're just starting out with the whole streaming thing, and I hope it will go well. Uh, Oh yeah, yeah, okay. It explains it here. The percentage is a symbol for module operator and returns the reminder of the division. Yeah, that's simple. Okay, so we already added continuous statements here. So you should skip 3, the numbers that are divisible by 3 and 5. Let's just compile it. Yes, save file, sure. And yeah, so we're already on exercise 14 now. Okay, we'll have question marks again. You can force the loop to exit immediately with a break statement. Yeah, makes sense. Continue expression do not execute when a while loop stops because of break. Okay, yeah, that makes sense. Oh dear, this while loop will go forever. Please fix it so that the print statement will give the desired output. We want end for. So yeah, okay, so we can just check if n equals 4, I guess, and then we can just say break here. Pretty simple. So every time the loop goes through, um, it will just execute this expression. So in our case, it's yeah, n plus 1. And then if we reach this condition, which is like n equals 4, we will break. And because we want to print n equals 4, um, yeah, I guess that's it. It should just work. Let's recompile this thing. Uh, pam, pam, pam. Okay, we passed. Now, exercise 15. Okay, wait, I think we have for loops now. Okay. Behold the for loop. For loops let you execute code for each element of an array. I wonder, like, an interesting syntax that I started to see, like, in more modern languages. Um, Not necessarily more modern languages, like a lot of languages. Uh, as far as I remember, a lot of like functional programming languages, I think Scala or Elixir, one of them, might have similar syntax on like picking out that variable inside the loops, like this, what is called, like these sticks, straight lines, right? I think Rust has similar thing as well for like um, pattern matching, if I'm not wrong. Yeah, I wonder why it was kind of revived because this is like very different from something like again the for loops in both Python JS because those are more closer to your traditional, I would say, like C for loops. So yeah, this is interesting. What's the reasoning? Because I don't really have an opinion whether this is like nicer or not. Maybe it's just aesthetics. Hmm. Maybe there is an implementation. Yeah, because this is being used for other things as well, not just only for loops, if I'm not wrong. So it might be the implementation detail, right? Or like, yeah, something performance related and stuff, possibly. Yeah, because for loop, yeah, I guess this is something that I would need to read more about. I was just thinking maybe because like the implementation of for loop is very similar to um, the implementation of like pattern matching, so therefore it just uses the same type of syntax. That would make sense. I might be wrong. I'm not sure what I'm talking about here. So yeah. Um, yeah, so what we want to do now is we want to iterate our story. So doesn't really explicitly tells us what to do. So what we're going to do is we're just going to try it. So story, iterate over story, and so it checks for scene variables. So I guess this should be seen then. Mm-hmm. Know that for loops also work on things called slices, which we'll see later. Oh, slices. Then slices might be the dynamic arrays that I'm talking about. I think Golang it has the similar terminology, but yeah, let's see because I might be wrong. So also know that the for loops have recently become more flexible and powerful to use of this exercise was written more about that in a moment. Okay, so let's save it, compile it, and all right, we passed. So we are on exercise 16 now. Exercise 16. All right. Expected. Okay, question marks again. Yeah. I'm just trying to read the compiler errors, but like in most of these exercises, it's just question mark problems. So it's like, not really helpful, but at the same time, I mean, it's fine, I guess. Because I thought at the beginning it would be more like um, having a deliberate compiler issue with some nonsense. I didn't mean like this type of nonsense of like having question marks, but the like for example putting in wrong types, or like at the beginning it was more like so like we would get some real compiler errors. For example, we'll try to reassign the const value, but like const variable, but now it's a bit more like just question marks. I guess it's whatever. For loops also that you use the index of the iteration. Okay, so that's something that I was asking. How do we get index in for loop? A number that counts up in each iteration. To access the index of iteration, specify the second condition as well as a second capture value. Does it? This dot. Okay, wait. You can name the item and index anything you want. I is a popular shortening for index. The item name is often singular form of the items you are looking through. Is it? Why it feels like I can just like iterate through two different like iterable things, two arrays, and then have a like a two what did it call, like capture value? Right, capture value, yeah. Wow, it does feel like it. Oh, yeah, this is interesting. Yeah, so can I can I try it? Um, so yeah, I'm just really curious now. So I just like um try something like this, and then do I have to have spaces here? Not. Okay, so semicolon. Then what will happen if I like try to put this here and then we just like oh my god, it's eating too much. Lol. Yeah. It does recognize it as you ate. And that's correct. Uh yeah, so I just want to try to print it. So std debug print so bit oops bit, and then we have this, and then it should be u, right? And then we have wait, how do I forget. How do we, can we just do like this? Oh yeah. This should be double quotes, right? So this should be double quotes, double quotes, double quotes, and then we want to have um this copied, I guess, and then we just like um yeah, we change this to what? Low, and then we just change this to low as well, right? So yeah, so let's just save it. Wait. This stupid pop-up, yeah. This should still give me an error, but will it show me the output? Hmm. Oh yeah, wait. We need to have the compiler um, errors fixed first. So what can we do here? Um, yeah, can I just like have const I um so does the casting there? So it's just like one. Can I do this? Just so the compiler doesn't complain. Uh-huh. Not found bit. Uh, what am I doing wrong here? Wait. That's probably not the way to. You know what? Let me try this way, and we also need to put lines here. Two. Yeah, so it does iterate over two different arrays. Well, you know what I'm going to do? I'm going to try to put some more. Uh, yeah, so now I'm curious. I'm very curious. So what will happen if I like um, have even more values here? So let's just change this to the rules this way, and then we just let's have it like as 3 here. Hmm. And then we are going to, what are we going to do? Yeah, we are just going to copy this. I misclick. So we're just going to copy paste this entire thing, right? And then this should be null, uh, null, um, null, and then we need to have here, and then we need to have here. Okay, wait, it does seem like we can do it. Damn, that's actually cool. Uh, yeah, not really. Is there any performance implications like doing this versus like iterating over like three different arrays 3 different times? What if they are different sizes? Wait. Uh, yeah, so like what will happen now? Should they, right? Yeah, okay, nice. Good. Okay, I see. It might be, yeah, it is probably more performant to iterate all of them once since they're the same length, I would say. I think so. Like it does make sense in my head. Interesting. Wow, that's cool. I have not expected to learn something like this today. That's very cool. Okay. Uh, yeah, now I forget where we're at. So, yeah, let's just like remove these guys. Um, um, oh yeah, so what he was saying is that like iterate over. I guess it's just like starts an iterator kind of thing, like which means like from zero to something, maybe. I think so. Um, yeah, I'm not really sure about that. So this should be I, and then we just like delete the rest of this thing. Um, yeah, I don't think we had this, and I don't think we should have this now. Wait, what are you saying here? As mentioned in the previous exercise, for loops have gained additional flexibility since these early exercises were written. As we'll see in later exercises, the raw syntax for capturing the index is a part of a more general ability. Or okay, are we going to learn about the fact that we can iterate over multiple arrays and iterators? Right, might be the case. So let's just compile it. Okay, we passed. Nice. Uh, yeah. So exercises. Okay, I see some weird import. Yeah, quiz time again. Let's see if you can solve the famous fees boss. Players can take turns to count incrementally, replacing any number divisible by 3 with the word fees, any number divisible by 5 with the word boss. And it gives a Wikipedia article. Um, yeah, that's very nice. Um, I want to do 15 exercises only, but I wonder if I can. if we should just like go ahead and complete the entire thing. Pa, 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 pa. Let's see, right? Because I think it should get much harder to understand all of this, right? For now, it's like pretty much more or less simple, just the syntax, right? Um, yeah, so this should be fn pop. No, wait, uh, pop fn. Yeah, public function. Yeah. So this should be at import, right? Did it was it? So it was like add import, and we have std. Yeah, I think I should disable my auto completion, but yeah, it's whatever. I don't really know how to do that. Yeah, with the console Emacs now yet. So this should be a while loop because we have a continuation expression like here. So it will be uh, adding 1 to I for each iteration. So this should be like while, right? Uh, now, yeah, okay, what is this? So if they are not divisible, wait, I forget what is this bus about. Incrementally divisible by reward piece and then number file for bus. Okay, this should then I guess this should be like fees bus. Wait, no, 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 not really. Wait. Should this really print anything? Fees bus. Uh, yeah. We just like compile it and then see what will happen. Cannot format array without specifier. Cannot format an array without specifier. Oh yeah, it's because of yeah. I'm just going to make it much simpler. Yeah. So we're going to remove this and then just save it and then we're going to compile it again. Okay. Uh, oh, oh, we just print the number. Okay. I don't really like know by heart what is FizzBuzz and how do we deal with that. So I'm just going to. So we should be then, right? Pa. Yeah, but otherwise I think we should be fine. Yeah, simple. Okay. So we have like stop at condition. We specify the variable u8, then we print module operator. Uh, mm, and that's a new keyword. Uh, so we can do this. Ambiguous use and for logical. Wow, it really says the like it tells us to use and or change white space to bitwise and yeah, it really tells us to use and. But then or should be or. What will happen if I use this? It also works. Huh? Um, LSP doesn't complain. I'm not really sure if I can use that way, but never mind. I mean, yeah, let's just move on. It's very interesting. Huh. Yeah, I'm going to read about this a little bit more, like the general syntax reference, because you really like put It is like it's just not something that they expected to have different ways of doing the same like thing. And when it comes to like conditions here, just not something that I expected. Okay. Functions. I have already created lots of functions called main. Now let's do something different. Okay, we are going to create a new function. So foo function. So it accepts n as u8 and it returns u8 as well. Pretty simple. So return is a return. The full function both takes number of n and returns a number that is larger by 1. Okay, note that the input parameter n and return types are both u8. Yep, sure. Okay, the new function deep thought. Ooh, DeepSeek mentioned. Is this AI? Should return the number of 42. See below. Answer to the ultimate question. Yeah, for real, this is an AI. What is this thing? When was this committed? Haha, I'm going to 18. 4 years ago. AI predicted. Let's go. That's cool. That's cool. That's cool. The Zeek developers, they knew about everything. Yeah, that was like right at the time when like I think GPT-2 was available at that time from OpenAI. Let's go. We should have listened to Zeek developers. Yeah, we're just missing a couple of things. One thing we are not missing is the keyword pop. To be honest, for real. This sounds like a something that I'm going to tweet about. Yeah. So let me just guess I'll just screenshot this. Yeah. Okay, let's continue. Please define the deep. Oh yeah, and if you want to follow me on X, it's just Swissaminifo underscore. So it's similar to my Twitch username, but underscore at the end. I don't tweet that much, but yeah, we'll try to. I'll try to provide as much value as I can, right? So yeah, let's continue. So the function details should return the number for two below. Please define the deep top function below. We're just missing a couple of things. One thing we're not missing is the keyword pop, which is not needed here. Can you guess why? I assume because we are on in the same file, right? Like, I'm not sure if like how Zeek actually manages all of this stuff, but like we're in the same file, same module, right? Type of thing. Um, so it should return. Do we need to put a colon here? Oh, not really. So it's just U8. So let's compile this thing. Okay, we're good. Right. So exercise 19. Now let's create a function that takes a parameter. Here's an example that takes two parameters. As you can see, the parameters are declared just like any other types. Name, type. Uh-huh. So it's just like different arguments to the function. Uh-huh. Makes sense. Please give this function the correct input parameters. You'll need to figure out the parameter name and the type that we are expecting. The output type has already been specified for you. 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4. So this is just accept the number and it would be what my number because it's already being used and we what will happen if I just leave it there? Okay, so it would what's there? Missing parameter name or type. Yeah, sure. Um this should be what I mean U8 I think will be sufficient for these purposes because it's just 1, 2, 3, 4 what we're passing. I'm going to save it. So stdmath poll type AB. takes a numeric type and two numbers of the type or the chemical and returns a to the power of b, so that same numeric type. So it will return u32, and it also expects the parameters here to be something that is u32 or something that can be um, coerced to that type. So u8 should be fine then for the my number 2. By default, I think it uses u8 for just some numbers here. Uh, yeah, wait, hold on. If I do something like this, so like just a number and then I um, assign it to 2, that should be comp time int. I don't have an error here. Unused slop, yeah, sure. Will it be u8 by default? Mm, What's the comp time int? I guess it's something that is being evaluated on the compile time to what, I wonder. Never mind. So this should just work now. We are passing, yeah. Passing with flying colors. Yeah, so we have question marks again for quiz 20, exercise 20. Let's see if we can make use of some things that we have learned so far. We'll create two functions, one that contains for loop and one that contains while loop. Both of these are simply labeled loop below. So it's at the bottom. Okay, you won't see this every day. A function that takes an array with exactly 4 numbers. This is not how you would normally pass an array to a function. We'll learn about slices and pointers in a little while. For now, we're using what we know. Yeah, it is like um, by default like provides a copy of the array. So can we directly modify it from the function or not? Or we have to do it by reference? Not really sure. So this function prints but does not return anything. Yeah, and I guess it should return something. Or no. Or should we just specify the type? So if it doesn't return anything, then we'll be void. And wait, what is this? Okay, so loop. Interesting. This should be 4. Right. Okay. What? Okay, and inherited. Yeah, yeah. All good, all good, all good. So this function bears a striking resemblance to the to there in the last exercise, but don't be fooled. This one does not. Does the math without the aid of the standard library. Yeah, it just does the manual mathematics. Okay, so I assume we'll be returning the total variable. So like it is already declared as u16. So yeah, that's not what I meant to do. So let's just yeah, let's just keep it as u16, and then we have loop again. This would be 4. Oh wait, no, no, wait. This would be while because we. I kind of see the continuation expression and this condition. We don't have the like um what is called like the capture value. Wait, how do I? Yeah, the capture value. Um, Total. Yeah, just power of 2, and then we want to return total here. Will it will it complain if I like try to return string? The LSP does not complain. I'm not sure if it will compile, and I'm going to try to compile it. No, the function, yeah, expected type u16 found const something something. Yeah, yeah, sure. Yeah, I know that strings are just an array of characters, but that's a still very weird way to tell me what it found. Yeah, it's like um pointer to the characters that are const with the size of 3 and u8. Yeah, because each character would be corresponding to its own what it's called something something. I don't even know the name. Yeah, but each character should correspond to u8. I think it makes sense. So yeah, that's like a lot of things I kind of like may or may not know intuitively. Kind of like have surface level of understanding, but there is still a lot to go very deep about, right? Yeah, and again, like in your average job, average web development job, because everything is just CRUD, glorified CRUD, complicated CRUD. It's like you don't really need to know all of this stuff, so you can get by very far without knowing it. So, but yeah, it's like it's not that I agree with that. I mean, I agree with the fact that you don't need it, but I don't really agree with the fact that you shouldn't learn this. So, hence that's why I'm learning. Because yeah, I'm pretty sure like learning Zeek or any other like similar type of low level language will force me to learn a lot of fundamentals that I'm missing out on. So yeah, so this should be total then. I'm curious why like LSP doesn't tell me anything, but when I try to compile it gives me an error. But whatever, maybe it's an LSP problem. Well, not a big deal. Um, so we're going to compile it now. Yeah, we passed. Okay, all good. The values are correct. Identifier. Ah, yeah, okay, something new. Believe it or not, sometimes things go wrong in programs. Okay, so error type. I'm going to take a small break here. Mm, just get some water, maybe get some tea, and then I'll be back. I think we might continue for a little bit more. I don't really mind. So far, it wasn't really hard to learn and understand and do these exercises. So I think we can just like go on for a little bit more. And yeah, but I need a small break, right? Before we jump into the new topic, the errors. So this might be very interesting. I think I know probably the first like small little project that we are going to build with Zeek. It would be the break timer for my stream. So I'm thinking some sort of just a CLI tool that would start the counter and kind of like announce that I'm on a break. Because right now I'm just like using like this canvas to show that I'm on a break. But the problem with this is that although it says like small break, 5 to 10 minutes, it doesn't really say when I went on a break. Right. So if there are like new viewers that are joining to the stream, they will not see when I went on a break, so they won't really know how long it took me. Right. So I guess that's something we can build in Zig, and that might be a very like small little tool that will develop. Right. Yeah. So that might be a good idea. Okay. So where are we? Exercise 21 errors. Um, let me just see. We have 5 exercises on errors, and then we have hello too. Yeah, so I think we're going to go through the all errors exercises, and then we'll do this hello too. I'm not really sure what it means, and then we'll just stop there for today, and we're going to continue on the next stream. Yeah, so exercise 21 errors. Believe it or not, sometimes things go wrong in programs. No shit. In Zig, an error is a value. Errors are named so we can identify things that can go wrong. Errors are created in error sets, which are just a collection of named errors. We have the start of an error set, but we are missing the condition too small. Please add it where it's needed. Yeah, okay, so the problem here is just like question mark, so that's the syntax error. Yeah, so let's see what's happening here. We are printing n inside the loop, const number error number fail n. Okay, so we have this function that accepts n u8 and then it returns the error. So if n is bigger than 4, we return too big error. If n is smaller than 4, we report too small error. This one is free. And otherwise we return 2 for error. So we just assign it. Okay, and then we can check it this way. I see. Okay, so we can just handle the errors this way. We just check if number error is like one of those errors. So if, yeah, in this case, this error would be too small. So number error equals my number error and then too small. Yeah, that should fix the thing. So and otherwise it's too four. So this would just fail in all cases. Mhm. So let's just that's what I meant to do. So let's just compile it. Okay, so we got it. So the output is basically just printing this. Okay, right. So exercise number 22. Common case for errors is a situation where we're expecting to have value or something has gone wrong. Take this example, text, get text, full text. What happens if get text can't find full text file? How do we express this in Zinc? Zinc lets us make what's called an error union, which is a value which could either be a regular value or an error from a set. hmm That's an interesting syntax. So it's basically saying that, yeah, it might return the value that we expect, but also, or basically, we might expect some error as a value as well. Yeah. For now, let's just see if we can try making an error union. Uh-huh. Okay, so we know this is U8. Okay, so wait. Looks like my number. Okay, because we are assigning an error here, it also means that it can be an error, and because it can be one of, so let's say like if we have um like here, if we have multiple errors, it can be one of like those, and that would be basically my number, not my number error, and then exclamation mark. So wait, not U8, right? Is that correct? Yeah. So it can be one of those basically. Okay, makes sense. So let's just compile it. Boom, boom, boom. And yeah, we're good. Now exercise 23. One way to deal with error unions is to catch any error and replace it with default value. Full can fail catch 6. Okay, so this means that if we get any kind of error, we just assign 6 to full. Yeah, if can fail fails, full will equal to 6. Okay. Mhm. Okay, so in that case, we don't have to declare the type as an error because we technically catch it. So it will be always a value that we provide after catch here. Okay, now the function is at 20. Please provide an return type from this function, hint to be an error union. So, uh, oopsie. So it should either return U8, no, U32, right? Because we can, yeah, since it's already like assigned here, um, yeah, it might be U32. And then but it can also return the error, so let's just try the same syntax that we just learned. So it would be my number error and then this way. So it can be either this error or U32. Mm, I'm not sure how I feel about this syntax. That's a bit weird. So like I kind of like what they do in like um, Golang, right? So it would be like Um, as far as I remember, like it will be something like the error type, and then it will be the value type, right? But here is it like um, the error or the type, the value type. Now, but okay, to be fair, the problem with Golang is that it's not like the compiler will tell you usually, so maybe it's not um, that big of an issue, but syntactically speaking, it's not really clear. It might not be really clear on whether the function can return error or not, because it's just like you just put those return values in like inside parentheses, comma separated like values, and here it's more like it's more explicit about that, like this is an error, like error union, basically an error type. I guess, yeah, I guess it makes sense in this if we think about it this way. Now, again, I might be wrong about Golang, I might be wrong about the implications behind like this syntax, but yeah, I can live with that. I think it's more explicit approach on declaring that the function can return an error. So yeah, let's just compile this, and then we should be good. So it's asking us if we want to save the file. Sure. Mm, yeah, we passed. Okay. So question marks again. So exercise 24. Oof, that's a big file. Okay. So using cache to replace an error with a default value is a bit of a blunt instrument since it doesn't matter what the error is. Okay. Cache lets us capture the error value and perform additional actions with this form. Okay, yeah. So we have like the capture value here. So it's like a kind of like a switch type of sentence, like the pattern matching, so we can actually check which error is what. Oof, that's a okay. This is convenient. Okay, I like this. This is very convenient. Very explicit and very convenient about what we're doing. Yeah. So the catch zero below is a temporary hack to deal with the make just right return error union for now. Okay. In this silly example, we split the responsibility of making a number just right into four functions. Make just right calls fix too big, cannot fix any errors. Fix too big calls fix too small, fixes too big errors. Fix too small calls detect problems, fixes the small errors. And then detects problems, returns the number or an error. Uh, yeah. Okay. Wait. What happens here? So make just right will return fix too big and catch an error, and if it catches an error, it just returns an error. Fix too big returns fix too small, and it can catch an error. And if an error is too big, it returns 20. Otherwise, it returns an error. And fix too small just runs the detect problems, which does this thing. Aha, so oh dear, this is missing a lot, but don't worry, it's nearly identical to fix too big above. If we get a small error, we should return 10. If we get any other error, we should return that error. Otherwise, we return the U32 number. Aha, so we um, want to catch here. So, that's not what I want to do. Okay, so yeah, the Zig mode functions a bit weird. Like when I try to delete word, it should just delete the question marks. But I guess because it doesn't recognize those, so um, yeah, actually, let me try. So if I just do like this, yeah, it just doesn't recognize question marks. So it will be catch and what do we do? Error, and then we do this. Am I correct? Uh, Catch, then yeah. So now, what is it complaining about? I'm not using error. Uh, Error, my name, unused capture. Yeah, sure. Okay. So if we get too small, okay. So now here we should catch the error. And return the correct error. Ah, so this returns errors based on these conditions or the number. So if error equals to my number um, error dot too small. Okay, so then here we just return, as it says here, we should just return 10. So we will return 10. Now, if we get any other errors, we should return that error. Otherwise, we return the U32 number, which I think it already does. Uh, yeah, so like we already catch the too small error, like we handle it separately. Now we can um, we can just return the error itself. Yeah, we can just return the error itself in all other cases. And otherwise we return user to number, which this function already does. Um, make just right, make just right. Yeah, I think this should just work. Yeah, we passed. Okay, that was interesting. I like the syntax about the catching the errors. Yeah, this example is a bit convoluted, but yeah, this is very convenient. I like this. It's very convenient. Okay, so exercise 25. Oh, nice. We don't have a question mark here. So invalid operands to binary expression error union and comp time in. So what is happening here? Okay, Zeek has a handy try shortcut for this common error handling pattern. Wait. For what? Exactly. Oh, so these can be written, what we learned just now, as try can fail. Okay, so what we will do? So we have an error, too small, too big. We have a function, okay, then we're printing stuff, and then this is a function, okay. So it can return an error or U32. This function needs to return any error which might come back from detect. Please use a try statement rather than a catch. So the compilation error here is because we are not technically handling the error here, and yeah, this function detect might return an error or U32. So when we do +5, because it might be an error, we can't really do that, and compiler catches that, which is nice. If we were trying something like this in Python, it will just blow up to our faces while we're running the program. Yeah, that's a good thing about compiled languages. Uh, so we can do this. So like what it does is it's essentially this pattern, right? But um, it's essentially this thing, but so when it errors, we do something else. Yeah, sure, but like I think I'm a bit confused. Okay, so if I try to do try, so this automatically becomes U32 because in case if we get an error, okay, so it will just return an error, I assume then. Right, what will happen if I like delete this type from here? Will it compile? Expected error union type. Line 18. Wait, why it expects? Oh, because there is a catch. Wait. So here it says expected type utility found error too small too big. Const X. Function cannot return an error. Yeah, so um this is what I wanted to see, but it tells me it's a not. And here it says expected type U32 found error small big. Wait, I'm now curious. Okay, we are just going to do what? Okay, we are going to delete like this, all of this. Um, and then I'm going to try to recompile this thing. Yeah, expected type U32 found error too small, too big. Yeah, because in some cases it will return this error. And it expected type U32. How is this uh happens? Yeah, is it simply because I don't have it? Okay, wait, let me just like um yeah, let me just like add this back. So my number error, yeah, and then wait, what happened here? So U8, was it U8, U32? Uh, U32. Hmm. Okay, so now we have the problem here. So expected type U32 found error too small to big. U32 can convert error union to pay the type. Consider using try catch or if, which says here. Yeah. Okay. Well, here it gives us some references. Okay, so it would be catch. Yeah, 0. Then catch 0, and then catch 0. Save, compile, and then now it should just work. Hmm. Okay. A little bit weird, I think, some of the reporting. Maybe I'm just too dumb to understand, but I feel like it could have been better. But I mean, it's all right. At least it told us everything that we need to know. It's just that the difference between like error and nose is a bit weird. Yeah. Okay. So exercise 26. Great news. Now we know enough to understand a real hello world program in Zeek, one that uses system standard out resource, which can fail. Uh-huh. Take note that this main definition now returns exclamation mark void rather than just void. Since there is no specific error type, this means that Zeek will infer the error type. Mhm. This is appropriate in the case of main, but can make a function harder or even impossible to work with in some situations. You can find more information at this website. Sure, we can check it out later. Yeah, let me just uh, I keep pressing Control. I keep trying to copy with the wrong binding, key binding. Let's just close this and then just open this up, and we'll have a read later. Yeah, this is the language reference. Okay. Does it really tell us about generic and thus becomes tricky to do certain things with it, such as obtain function pointer or have an error set that is consistent across different build targets. Additionally, inferred error sets are incompatible with recursion. Why? In this situation, it is recommended to use an explicit error set. You can generally start with an empty set. Like, is it about some compiler optimizations that it's doing that will make it hard? Add an explicit add an invert with invert error set. Uh-huh. Okay, we can understand this now. Test invert, add invert, unreachable. What is unreachable? Oof. What is this? This looks this looks a bit complicated now. What's happening here? Um, yeah, maybe it's a part. No. I think it's just a part of like if. So if add invert, then we have the capture value unreachable, else error, switch error. Why is this weird syntax? Can we just use like catch here, or maybe it's just because it's a part of a test? Okay, we will need to figure this out. yeah, I still don't really know why, like, why are these up? Why we can make this work? Maybe we'll, yeah, maybe we'll understand this later. Yeah, this is like, I guess, like one of those things where if I had known some fundamentals, it would be much more, probably much more simpler for me to understand. But yeah, because I'm just an your average developer, maybe even below average, it would take some time for me to learn and understand this, and that's a good thing. I'm like very happy that I started this journey. I mean, just at the beginning, but I'm already learning a bunch, and there is already a lot of gaps that I see in the knowledge that I'll have to go through. And I will do it off stream because it's a bit boring to watch that, but I think it's still very important to like actually try to push yourself and learn all about this. And what's more important, like half of the problem is even knowing what you don't know. And in our case, like I already know, I can already see what I don't know. I already see what I need to learn and read more about and try things. So it's very good. It's very good. I like it. Now, yeah, unlike std debug print, the sound out writer can fail with an error. We don't care what error is. We want to be able to pass it up as a return value of main. We just learned of a single statement which can accomplish this. Okay, so we initiating std out. Yeah, is that like the famous? Wait. I'm not curious. Is that the famous "Hello World" on the on the Zeek homepage? Zeek. No. That's not what I wanted. Yeah, I was googling a lot about Emacs and all that stuff. Documentation. Introduction. Zip library. Yeah. So like that's the first thing that you see on introduction of the Zeek language. So very verbose hello world, like super verbose. I was watching the stream by Sodding. Sodding is the Sodding. So this guy, he had a Zeek stream, and yeah, he was laughing about how verbose is this hello world, and yeah, I kind of agree. Like that's a lot of stuff here. But I mean, if we think about it, like it all makes sense. But yeah, it is very verbose. So yeah, then this would be just try since we don't really care about the error here, right? Um, and then we passed. I'm now curious what will like um can I can I like do yeah, it's essentially the same thing, right? So I can just do this as well. So um return what is called return error. Oh my God, like look at this speed definition. Like it shows me the type of this error, and that's a big error. But that's a nice thing because it's already like documenting everything, and it tells me what kind of errors I can encounter with the std out print. Interesting. Yeah, so let me just see if this compiles. I guess it's wait. I'm doing the wrong thing. I'm doing the wrong thing again. So that will be this. Project compile, and how do we do it? dn equals what is this? 26. Yeah, it does compile. So it's yeah. Like we already learned about this, so I just wanted to like double check, just to ingrain it in my memory. So it's essentially the same thing. Yeah, so that would be try here. Yeah. So we save this, we compile it, and we're good. Yeah. Okay, so we are on exercise hello 2, so 26. Okay, so um, I'm going to end the stream here. Um, we learned a lot. We learned about basic syntax, variable assignment, constant variable, like var keywords. We learned about arrays, we learned about strings, we learned about ifs, while, for loops, we learned about capture values, we learned about handling the errors, We learned how to declare functions, return types, parameter types. We learned a bunch of types here. Uh, we learned about the fact that I can use one for loop to iterate over multiple arrays, which is quite cool. Uh, we learned how to define an array variable, for example, without assigning any values using undefined. So we learned a bunch of stuff. Of course, this is something that I would need to practice on more and more and more. So, but yeah, for today's stream, I think that's enough. Uh, so tomorrow we are going to continue and learn. I see the defer statement, so I would imagine it's similar to Golang, so the function that executes something that executes when the function ends. So yeah, we're just going to go through that slowly, slowly. I see some hard topics for me that I will struggle with. I see pointers here, but I guess it's fine. So we're just going to go through that later. But yeah, that was enough for this stream. If we are being fair, that's a lot of information for me to process as well. So I hope it was enjoyable to watch, and yeah, thank you. Bye bye.